Now this is problem 4 of, exercise 4 of problem set 1. In this exercise, they're asking me, among all possible connected networks with n nodes, what are the values of the largest and the smallest possible diameters, the max and the mean, respectively. So we have from all possible connected networks with n nodes, which is the one that has the maximum diameter and the minimum diameter. That's the idea. So let's think of this problem. Remember that the diameter of the network is the longest path, okay? Is the longest, shortest path of the network. So if I pick all the distances between the nodes, okay, for all ij, then the diameter is going to be the maximum, okay? The maximum dij. This is going to be the diameter of the network. So let's think of different network configurations, okay? So this is an easy one. So for instance, if we have different, for the case of the minimum value, I think it's quite obvious, because in the minimum value, in order for this to be, if the smallest possible distance between two nodes is going to be 1, okay? So if we want this distance, that the maximum distance between all nodes in the network is 1, then that's only possible. It's going to be 1, that's only possible if it's a clique, okay? So if all the nodes are connected to all the other nodes. So all nodes connected together. And when I mean connected, when I say connected, what I mean is that they are linked, okay? They are linked, because connected is when I can go from one node, these 3 nodes are connected, okay? Because I can go from here to here, but this is not, in this case, this node is not connected to this other one, okay? So in this case, we would have here, in this case, all possible nodes connected. So that's the case, okay? So the minimum diameter is going to be when all the nodes are connected, are linked to all other nodes. And the maximum value, they have to be connected, okay? So it has to be a connected network. So I think that the thing that makes sense is that this is going to be like a line, okay? So we have that all nodes are in a line. So if this is node 1, node 2, node 3, and so on until node n, then we would have that the distance, the maximum distance would be from this node to this other node, okay? And it's going to be n minus 1. So the max is going to be equal to n minus 1. So this is the two possibilities.